Hello and welcome to Chapter 9, Section 2. Today we talk about characteristics of a quadratic function. One of the things that quadratic functions have is a zero. The zero of a function is an x value that makes the function equal 0. So this is where we have an x-intercept, where the graph intersects the x-axis. And so here we have three examples of parabolas on a coordinate plane. It's possible, if your vertex is on the x-axis, for your function to have 1, 0. You can have 2 zeros to your function where it actually crosses the x-axis. There are parabolas that never cross the x-axis, and so they don't have zeros at all. So here we have three parabolas, and we are asked to find the zeros from the graph and check your answer. So here we have our vertex and our 2 zeros, our spots where it crosses the x-axis. And these cross on very specific spots. And this one crosses at 2, 0, and this one crosses at -1, 0. So 2 and -1 are our zeros. 0 here, we're pretending that I can draw and that it intersects at exactly this spot. This is at 1, 0, so our 0 is 1. And here we have a parabola that does not cross the x-axis, so it does not have a 0. So you're going to try and find zeros on some parabolas for you. Checkpoint number 1, pause here, try the problems, and come back when you're done. So with problem 1a, this is a parabola that opens down because a is negative, and so it has no zeros. This problem, y equals x squared minus 6x plus 9. So this graph crosses the x-axis at 3, 0. So it looks like 3 is our answer, and we want to check our answer to make sure it's not 2.9 or 3.15 or something like that. So we're going to drop a 3 in for all of our x's. We're going to end up with 9 minus 18 plus 9, and that ends up equaling 0. So that is our 0. So we have checked our answer. Another characteristic of a quadratic equation is that they have an axis of symmetry, a vertical line through the vertex going straight up and down, making two symmetrical halves. They are mirror images of each other, and we can actually use the zeros to find the line. If there's only one 0, then you know that the 0 is in the vertex. So whatever x equals, if there are 2 zeros, you're going to use the average of the 2 zeros to find the axis line, because the axis line is going to come right in the middle. So let me give you a couple of examples. In this parabola, we have it sitting on the x-axis, and it's sitting at, and again, pretend I can draw, 3, 0. So it's got 1, 0, one spot where it intersects the x-axis, so our 0 is 3. This parabola has 2 zeros, and we don't know what this point is, but we do know that the 2 zeros are -5 and -1. So we're going to find the average of -5 and -1 by adding them together and dividing by 2. -6 divided by 2 is -3. So -3 is our axis of symmetry. And x equals -3 is that line. So if it's got 1 0, then this is your axis of symmetry. If it's got 2 zeros, then this is your formula for axis of symmetry. Okay? Give checkpoint number 2 a try. Pause here and come back when you're done. So 2a looks like this. It is sitting on the line right here at -3. So our 0 is going to be -3, and our axis of symmetry is going to be x equals -3. Here I've got a parabola that I don't know what the vertex is, but I do know that the two zeros are x equals -2 here and x equals 4 here. -2 plus 4 divided by 2 is 1. So I know that if I drew this right, which I obviously didn't, the line of symmetry would actually be on x equals 1, which is why you don't want to rely on my pictures, you want to rely on the book pictures. Okay? If there are no zeros, there's actually a formula you can use to find the axis of symmetry. And this is actually a great formula because it's the quick way to find a vertex as well. We're going to look for x equals -b over 2a. So we're looking at this a and this b. So we're going to just jump right to it. So if we had an equation that looked like this, our axis of symmetry, x equals -b 4 over 2 times a, which is 2. -4 over 4, which is -1. So when we're graphing it, that line up and down at the -1 is our axis of symmetry. And we know that our vertex is -1 comma something. Let's try it again. Y equals -2 squared plus 3x plus 4. So x equals -3 over 2 times 1. -3 halves, or -1.5. One more. X equals -b, which is 1, -1 over 2a, -1 over 4. Okay? And when you graph that, -1/4 is like right there. It's 1/4 of the way to the 1. Okay? Now we're going to take that same formula and we're going to use it to find the vertex of a parabola. We're going to start by finding the axis of symmetry because that gives us our x point. And we're going to put our x coordinate into the function and solve for y, and that's going to give us the y of the vertex. For example, so we've got this here, x equals -b over 2a. So it's 10 over 10, which is 1. So we're going to stick 1 back into this. Y equals 5 times 1 squared. 5 times 1 is 5 minus 10 times 1, which is 10, plus 3. 5 minus 10 is -5 plus 3 is -2. So our vertex is 1, -2. Let's try another one. X equals -b over 2a. 4 over 2 is 2. We're going to stick 2 in here. Y equals 2 squared, which is 4, minus 4 times 2, which is 8, minus 10. 4 minus 8 is -4 minus 10, which is -14. So our vertex is 2, -14. If we were solving this problem, x equals -b, nope, -b over 2 times a equals 2 over -2, which equals -1. And if we stick -1 in for this, -1 times negative, so remember you're going to do this first. -1 times -1 is +1. And it's a negative, so we've got -1 minus 2 times -1 is +2. And that equals 1. So our vertex is -1, 1. And that's exactly what that practically looks like. So stop here and do check it out numbers 2 and 3 to make sure you've got these concepts. Pause here and come back when you're done. So here we have a parabola that sits on the x-axis at that -3 spot that you can easily see. So I didn't use a piece of graph paper because I've misplaced it, but here we go. X equals -3 is our axis of symmetry. Here we have a parabola that has two zeros, one at -2, one at 4. We're going to find the average of those two numbers, and our axis of symmetry is 1. And for number 3, with this equation, we're going to use x equals -b over 2a as our formula, and we're going to plug in our numbers, and we're going to get that x equals -1/4. Please ask if you have any questions. And before we move on to word problems, please check it out number 4 to find the vertex as well. Pause here and come back when you're done. And I feel like I did this problem for you already, but you tried x equals -b over 2a, and x is 2. You plugged 2 back into the equation, and you got -14 as y. So your vertex is 2, -14. Now on to word problems. Now please realize that the word problems are finding a word description way to ask you the same question it's been asking you. So one of the things it does, it's looking at a bridge, and this is a rough sketch of the bridge, and notice it's got a parabola in it. And it gives you the equation f of x equals -0.007x squared plus 0.84x plus 8, where x is the distance in feet from where the arch enters the water. And the question is, can a 24-foot sailboat fit in here? And it's passing under the vertex, so we want this to be more than 24 feet from where the water touches the supports, which means we want to find the vertex, and we want the vertex to have a height of at least 25 feet, where this is y and this is x. And we want the vertex to be at least 24 feet. So we're going to find the vertex. And when we find the vertex, we're going to work out x equals -b 0.84 over 2 times a, which is -0.007. And when we do this math, that equals 60. So x is this way, 60. We're going to plug 60 in for x to figure out what y equals. Equals -0.007 times 60 squared, which is 3,600, plus 0.84 times 60 plus 0.8. And when we do that math, we realize that y equals 26, which means that this is 26 feet up, which means that, yes, a 24-foot sailboat would go through it. Your homework tonight starts on page 624. It is numbers 19 through 35 all, which is 17 problems, and number 36 is 4 points of extra credit because it's one of those big problems, but it's walking you through a very similar problem to what we've been doing. So give it a shot. Extra credit points never hurt. Okay? Please remember to ask questions if you need to, and I will see you tomorrow.